Hello, my name is Qinghua Chen. Here's my answers for homework 3 problem 1. Let's look at part A. Uh, if you want to figure out the value of B, we need to use the condition that probability of x equals k represents a probability mass function. So we can know that the sum of b multiply k multiply p to the power k minus 1 equals 1. And we know this one equals this one, the limit of k close to infinite. Then we can multiply b with the both sides. Then we can get this equation. Then we use equation 1 minus equation b. Then we can get this equation. And we know this formula can be simplified to this one. And then we get that if k is close to infinite, we can get the right formula to b over 1 minus p. So we move 1 minus p to the right, then we get s equals to b over 1 minus p to the power 2. And we know this is equals 1 because probability of x equals k represents a probability mass function. So we can know that b equals to 1 minus p to the power 2. Then let's look at part B. As we have figured out in the part A, we can know the sum of b multiplied with k multiplied with p to the power k is equal to bp over 1 minus p to the power 2. Then we can differentiating both sides with respect to p. We can get this equation. First, we differentiating the left side, we can get this one, and with differentiating the right side with respect to b, we can get this formula, and then we simplify this formula to this one, and we use the b which has been figured out in part A. We can get 1 minus 1 plus p over 1 minus p. So we can get the expectation of x. It is equal to sum of k to the power 2 multiply with p to the power k minus 1 from 0 to infinite, and this is equal to 1 plus p over 1 minus p. Then let's look at part C. At the step above, we can use the same method to get the expectation of x to the power 2. As we know, sum of b k to the power 2 p to the power k from 0 to infinite equals to b multiplied with 1 plus p over 1 minus p to the power 3. Let's differentiate both sides with respect to p. We can get then we can get the expectation of x to the power 2. we can simplify this one and then use the value of b. We can finally get the this answer. 2 bracket 2 plus p bracket over 1 minus p to the power 2. Then we all know if we want to figure out expectation of x to the power 2 minus the expectation to the power 2 of x is equal to we just can use the answers figure out in the part B, and part C we can figure out the answer of the part D. Then let's look at part E. If the P equals to 1 over 1/3, then we can get the exact probability of x is equal to k equals 4/9 multiplied with k multiplied with 1/3 to the power k minus 1. Then we all know probability of x bigger than or equal to 2 and x is smaller than 5 or equal to 5. This probability is equal to sum from k equals 2 to k equals 5. The sum of 4 nines multiplied with k multiplied with 1/3 to the power k minus 1. Then we can get the answer 392 over 729. So we can get the conditional probability mass function of the k minus x equals k given that x bigger than or equal to 2 smaller than or equal 5. Its probability is when k is smaller than 5 or equal to 5 and bigger than or equal to 2, the probability of this one equals to probability of k x equals k over p of this, and we can get the final answer is 81 over 98 multiply k multiply 1/3 to the power k minus 1. It's only when k is bigger than or equal to 2 and smaller than or equal to 5. Otherwise, the probability equals 0.